Welcome everyone. We are going to learn thio compounds today. What is the meaning of thio? Thio is another name for sulfur. Thio or thio, that means sulfur. So this word comes from Greek. Okay, the meaning is thio. So many of us have confusion in this one. How to create the formula with thio. So first thing, say example sulfate. This is sulfate. This is sulfite. So now I am going to exchange the sulfur, right? And also I draw the Lewis diagram next to this, you can see. And you can put a double bond if you want, or coordinate covalent bond. This is a sulfate ion. Now I'm going to replace one of the oxygen somewhere here with sulfur. So sulfate, I take away oxygen and substitute sulfur for that. So I have 2 sulfur now and 3 oxygen. The charge remains same, no change at all. Right? So here the structure now changed to I should put 2 lone pairs here. You can draw the dots, that's easy, but for time saving. Sulfur. Okay, so likewise you can interchange the sulfur for naming purpose only. Sometimes these compounds are not existing, but still in grade 11 chemistry, they are expecting how to modify the or derive the name from the parent name. Parent name is here it is sulfate or sulfide. From that you are going to derive the new formula. So here if you take away oxygen and add sulfur, then S2O2 2 minus. So the name of this one is thiosulfate. This one thiosulfite. Now we will do some practice. So for an example, the question given, again sulfur and oxygen are in the same group, so that's why this is happening, because valence electrons so is same for both of them, so it is possible to interchange. Now if they give sodium S2O2 like this, you cannot simplify this one. First thing you have to do the reverse crisscross for this one. You have to separate the cation and the anion. So you all know Na has a +1 charge because it is group 1 element, right? So group 1 element, so it has a charge of 1. So Na has a charge of 1, right? And S2O2 you separate, and then this charge goes back to there, so negative charge. So now you have to examine what is this one. So when you examine this one, so it is difficult to see. So what you will do, reverse operation. Take away sulfur and add the oxygen to see what was before. So now if you take away oxygen, take away sulfur and adding oxygen, so it has become SO3 2 minus. So this is sulfite. So therefore, this one is thiosulfite. I hope you understand this one. We will try another example. Okay, so carbonate. So I am giving a compound MgSO2 like that. So now you have a question, what is this compound, right? So separate again cation separately and anion separately. So when you separate the cation, you all know magnesium. Magnesium has a charge of 2 because it is in the second group. So it will lose 2 electrons and get the charge of 2 plus. So if I do the reverse crisscross for this one, magnesium automatically become magnesium 2 plus. So that means there is no other charges here. So here 2, so that is going there. So it is become CSO2 2 minus. So CSO2 2 minus. Now we had to do the reverse operation to see what was the parent one. So I take away sulfur and add the oxygen to see what was before. So if I remove the sulfur and add the oxygen, it is become CO3 2 minus. So this is carbonate. So this is carbonate. And then this one then from here what we can conclude, this is thiocarbonate. So now the name of this compound is magnesium thiocarbonate. Okay, so similar, you can try for not only carbonate, you can try for phosphate. So this is phosphate. So if you remove one oxygen and add the sulfur, that is become PSO3 3 minus. Again, the charge not changed. Charge is remain same. Only oxygen replaced by sulfur. So this is thiophosphate. Okay. So now imagine I am giving a compound, right? Sodium. So we have to do the reverse operation to see. So this charge goes here. Again, sodium has a charge of 1. Sodium has a charge of 1. PSO3 has a charge of 3 minus. So now we do the operation for that one to figure out which one is the parent one. So I take away sulfur and add the oxygen. So PO4 3 minus. So this is phosphate. Therefore, this one is thiophosphate. Okay. Now I will give another one without giving the parent ion. We will try that one. So look at this compound. Okay, so now it is confusing. Which one is this compound? So first thing, we will separate the cation and anion. So you all know this goes here and this goes here, reverse crisscross. So Cu2 plus and then PSO3 minus. So still it is confusing. What is this one? PSO, it is a sulfate or it is a phosphate kind of confusing. So but still there is a 3 minus charge. So it is not sulfate derivative. It is a phosphate derivative. Right, so this is a phosphate derivative. So now I am going to take away the sulfur and add the oxygen to see what was before. So if I take that one and replace with this, so it is become PO2 3 minus. So PO2 3 minus is hypophosphite. So this one hypothiophosphite. So the name of this compound, copper has multiple valencies. Copper has copper 2 plus, copper 1 plus. So we have to specify which one. Still it's a transition element, multiple valencies. So now copper 2 in Roman letters, uppercase 2, hypothiophosphite. So that is the name of that compound. Okay, so we try another one. Zinc. So now again, you separate these two into positive ion, negative ion. So zinc 2 plus and CSO 3, 2 minus. So now the question is, it is a sulfate compound or carbonate compound, but we learned there's no like different carbonates, right? There is no similar for sulfate thio, there is no such a thing for carbonate. So this is actually carbonate compound. So now I remove the sulfur and add the oxygen to see what was the parent ion. That is CO4 2 minus. So this is percarbonate. So therefore, that one is per thiocarbonate. Okay, so some compounds are this thio compound. Just for practice we are doing. Okay, only a few of them are available. So for an example, this is available as a thiosulfate all the time. And another compound I will give you here. This is called cyanate. I'm writing the cyanate formula. This is cyanate. Okay, so if I take this one, I remove that one. This is called thiocyanate. Okay, so what happened? CNO minus, take away oxygen and add the sulfur. So it is CNS minus thiocyanate. So this is available as well. So this is existing. This is existing. But most of them not. But for practice, we are how to modify name if the system, right? So it's a IPEX system, naming system. If you want to create a new name in future, right? How do you modify the name by sulfur thio compound? So these are the questions normally confusing. So this is thio compounds. So now the next one, we are going to learn how to name the acid compound, acid radicals. So we will see that one. How do we do the acid radicals? So say I pick phosphate, right? So the meaning of polyatomic anions, this 3 minus indicates this anion from an acid. So in other words, these anions are from acids. After that acid release their hydrogen or proton. We can say proton or hydrogen because hydrogen has only one proton. It doesn't have neutron. So hydrogen ion after it release. So this is the parent acid. When the parent acid reacts with a base, right? Say for an example, sodium hydroxide is a base. Is when it is reacts. So it reacts NaOH and H3PO4. If you balance it, Na3PO4 plus 3 H2O. Physical states AQ. So now the phosphoric acid hydrogens are replaced, right? Removed. This is a phosphoric acid. Structural diagram, not the Lewis diagram, not complete. If I want, I can change to Lewis diagram. Okay, so instead of drawing dots, I draw this one to save some time, but you can draw the dots, that is better. That's actually Lewis dot diagram. So here you can see 3 hydrogen. So this hydrogen, right? So once it remove this hydrogen, the formula turns to this one as it is, this one as it is, and this one as it is. But this one, now it has one pair of electron extra because when the hydrogen leave this one, hydrogen electronegativity is 2.1 or 2.2. You can use a similar approximate value for understand. This is somewhere 3.5 approximate value. So hydrogen cannot pull the electron, but oxygen pull the electron with a strong pull because nucleus of oxygen has more proton than hydrogen. You can look at what are the factors affecting the electronegativity and then you can conclude. But at this point, electronegativity of oxygen is greater than hydrogen. So oxygen release the hydrogen. So hydrogen is now left the phosphoric acid. So this one has 2 hydrogens. So you are specifying the name dihydrogen phosphate. Everything same, but it has, so now it is an ion has 1 minus charge, right? So further, if this one release another hydrogen, so I redraw the structure, and then you see this is the, so it released other hydrogen as well, second hydrogen. So now it has one more hydrogen, right? Here it has two hydrogens, so we say di. Here it has only one hydrogen, so we had to say mono. So this is monohydrogen phosphate. Okay. Further, if it is released one more hydrogen, that is become phosphate ion, just phosphate. Okay, so this is a phosphate ion. The rest all ions too. So dihydrogen phosphate ion. This is phosphate ion, monohydrogen. But the original one is phosphoric acid. Sir. Phosphoric acid. So this is phosphoric acid. Now, from the phosphoric acid, we can derive many. Now, if I change this one to sulfur, this is sulfate, or sorry, sulfuric acid. See, sulfuric acid. Sulfuric acid. So look at their derivative. If it is lose one hydrogen, right? So this lost this hydrogen. Can you see this hydrogen is gone? It's not there. That is here. This one is called hydrogen sulfate. Okay, here we won't use the word mono because it is only one hydrogen left, right? So you don't need to specify mono or di. Or there is another name for this one, bisulfate. You can use that one too. But there is no bisulfate or biphosphate. There is no biphosphate. Not available because there is a two phosphates there, dihydrogen phosphate and monohydrogen phosphate. So which one is biphosphate? None of them. So you have to specify which one. There is another old nomenclature is there, like you don't need to worry about that one, just di and mono. Okay, so this is one hydrogen. After another hydrogen lost by this is equal to now 1, 2, 3, 1, 2, 3, and then it has 2. Now this is sulfate. So this one is sulfate. Can you see another hydrogen? Here, that hydrogen is now free. It is an acid. It lost that one, right? So you can see that one. So this is sulfate. So that is the connection, right? So this is the sulfate ion. This is hydrogen sulfate ion or bisulfate ion. That is sulfuric acid. You can go in a reverse order too. You can go here to here, here to here, here to here, and here to here. You can move here as well. So there is a confusion for many students. Why mono dihydrogen phosphate, but there is no monohydrogen sulfate? Because it is only one hydrogen. So we don't need to specify. We won't make the naming system complicated. If it is only one present, then you don't need to specify one is there, but there is many, 1, 2, 3, like that situation, then you have to specify mono, di, tri, those kind of prefix you have to use it. So I hope this one makes sense. And in the middle, you can see this hydrogen. So if I have, say for an example, sulfide, right? So sulfide, it is coming from hydro. This one is called hydro sulfuric acid, right? Hydrosulfuric acid when it is in aqueous. So when it is lose first hydrogen, it become hydrogen sulfide ion. So you can say hydrogen sulfide ion. You don't need to specify monohydrogen because it is only. Otherwise, you can say bihydrogen, sorry, bisulfide ion. If it is lose the further one hydrogen, it is become S2 minus. You can see this hydrogen is now free. So this is the acid derivatives you can do for all the polyatomic anions and the anions like this. So then you will have hydrogen. But make sure the charge is changing, right? So here this one has 1 minus charge, 1 minus charge, 2 minus charge, because each time when it is released one proton, the negative charge is increasing by 1. So here I haven't put the hydrogen, so the hydrogen is this one. So you can see how these hydrogens are released. Okay, so the charge is increasing in negative charges increases because every time it is releasing one proton. Or other way around, if you want to say sulfate ion, you can bring to sulfuric acid by adding one hydrogen. When you add each hydrogen, right, the charge is decreasing by 1. Now we practice one example, one or two examples to understand. NaH2PO4. So you separate cation and anion. So cation is Na plus, anion is H2PO4, H2PO4 1 minus, because this is 1 because it is group 1. So it has a charge of 1 plus, right? So it is group 1, charge of 1. So this one, 2 hydrogens here. So you will say dihydrogen. And this is phosphate. You have to verify that one. Phosphate. Okay, so we will do combine with thio compound. Can you look at this one? Sodium H2 PSO3. Again, if you separate cation and anion, you will have Na plus, and the other hand you will have HPSO3 1 minus. So now you have to do the logical way. You have to remove the sulfur and then add the oxygen and see which one was the parent one. So that one is H2PO4 1 minus. So this is dihydrogen phosphate. So therefore, the original one, dihydrogen thio phosphate. Dihydrogen thiophosphate. So the compound name now, sodium dihydrogen thiophosphate. Okay, so you can try another one similar to this. I keep the sodium as it is, HCSO, like this. So now you will figure out what is this one. So first separate these two. Sodium has a charge of 1 plus, so HCSO 1 minus. So you have to look which one is the parent one. So you remove the sulfur and the oxygen. So now you will have HCO2 1 minus. So this is hydrogen carbonate. So if you go this way, that one is become hydrogen thiocarbonate. So the name of this compound, sodium hydrogen. Here we won't use the word mono, right? Because it has only one hydrogen alone in that acid radical. Carbonate. Okay. Now everything together. Can you see here in the screen? You can see thio compounds and acid radicals using a periodic table. This is applicable for, if you use the same, you can use phosphate one, you can apply for arsenate, same thing, carbonate for silicate, um, phosphate, sulfur, tellurium, polonium, selenium, all, sorry, sulfur, selenium, tellurium, all of them same pattern, and then chlorine, bromine, iodine, you can again use the same pattern to make their chlorates, carbonates, thio compounds, hydrogen phosphate, monohydrogen phosphate, like dihydrogen phosphate, dihydrogen arsenate, monohydrogen arsenate, hydrogen selenate, hydrogen tellurate, hydrogen silicate. All these you can derive from the parent ion, the similar pattern. Thank you for watching, and thank you for your thank you for sharing. Have a good day.